Hi, my name is Sean Healy. I work for the Rocky Mountain Research Station Inventory and Monitoring Program. And this is the first of two videos about carbon and the National Forest System. There are two reports that have been produced and released supporting managers of the National Forest System. And we're going to talk about both of them. Before I do, I just want to recognize that there are a lot of people, including Rich Birdsey, Alexa Dugan, Duncan McKinley, Sam Gogish, and Karen Dante Wood, who have contributed to this video, and then there are others who have contributed to the next video. So the reports that we're talking about, there are two of them. One has been released for the last 2 years. The other is just coming out now. The first talks about carbon stocks, how much carbon is stored in the national forests and how much carbon is stored in wood products that have been harvested from the national forests. The other report is an assessment of the impact of management and disturbance across the national forests. And I want to emphasize that each national forest is sort of treated equally. These are standardized national reports, but they're tailored at the national forest level. So the idea is that they provide a menu of analyses and results that can be used to assess carbon. And I say at the bottom of this slide here that this is relevant for the 2012 planning rule. There are other mandates for assessing carbon. We're going to focus on the planning rule in this video. So, as I say, these two reports are available, and these videos basically are doing three things: helping managers focus on carbon information that's relevant for their own local context. So I'm going to say this many times that the results presented in these reports cannot be interpreted as in a vacuum. They occur on every particular national forest, and each national forest has its own story. And the carbon, the signals in that story can be seen in carbon, but the carbon reports and the information in those reports is really meant to be interpreted by what's happening on your forest. Secondly, I'd like to have you understand the basic data that's supporting these results. And lastly, because people have to use this data in assessments that go into the planning process, I'd like to help managers make sense of and choose among the results that are presented in the reports from different tools. As you can see from this slide, carbon in the atmosphere can affect the Earth's radiative balance. In other words, just like the greenhouse effect, the more carbon that's in the atmosphere, the more resistance there is to energy bouncing off of Earth and out into outer space. So it affects the climate. So what do trees have to do with this? Through the process of photosynthesis, trees and other plants in the forest take carbon out of the atmosphere and store it in plant material, mostly in wood. And there are many pools. There's above ground and below ground pools. But that's an important reservoir of atmospheric carbon if the forests are growing. After a tree dies, for instance, from old age or from fire or harvest or insects or other disturbance processes, that carbon is not immediately released. It can stay in stumps, in down dead wood, or it can be exported to the forest product sector. In either case, there's a delay in the release of that carbon back into the atmosphere. So as I said, the forests and forest products are sort of a reservoir that keeps carbon out of the atmosphere. So how important is that reservoir? How much carbon does it store? So this slide shows you the amount of carbon stored in all U.S. forests broken down into the different components of where it's stored, they're called carbon pools. So there's above ground, there's organic material in the soil, there's below ground there's products in there. So what's the magnitude of this storage? And really this is a climate change mitigation benefit that we see. So I'm trying to quantify how important is it. So what we see here is results from FIA, the Forest Inventory and Analysis Unit's assessment based on inventory about how much carbon our forests are storing. And what we see is it's about 350 trillion barrels worth of oil in US forests. That's a lot. That's about 50 years worth of our current consumption of oil. So if we cut down all the forests and all that carbon was immediately released into the atmosphere, it would be as if we had 50 years of burning fossil fuels at our current rate. It's a very important pool. I want you to notice from this, because we're going to get into it in a second, that this pool, when looked at from this level, is not really changing that quickly. We see 2013 and 2014, and the total is not that different. As we go through these slides that make up this video, I'm going to have little side notes that will help managers, basically managers who are using the two reports, make sense of or do little cross calculations of from the reports. And this one is basically showing you the petroleum equivalent for carbon totals that are cited throughout the report. So that basically the reports talk about megagrams or metric tons. A metric ton is equivalent to 1,000 kilograms. But there are references that you can find, and this is one of them. At the bottom of the page it says conversion factors. You can get these conversion factors to go from the carbon, the biomass numbers that are in the reports to barrels of oil or miles driven or something like that, if you want to connect these results to things that the people who care about your forest can relate to. Okay, so I mentioned that the total carbon storage in the United States is not changing that much. And I just want to, at the outset, put in a little plug to not obsess about source versus sink. So a sink is an ecosystem or a pool that is taking in carbon faster than carbon is leaving it. And a source is the opposite. It's emitting carbon faster than it's taking it in. And there is a tendency a lot of times for people to find out that their piece of land is a source or a sink and to panic one way or the other. I don't want to minimize the importance of whether your bank account in terms of carbon storage is going up or down. Obviously, if you have a bank account, you care whether it's going up or down. But you probably don't care about it on a day-to-day basis. You might write a check and things look bad, but you might have a payday and things look good. So I don't want you to obsess about the sink versus source status, at least not on a yearly level. So a few other reasons to not obsess about whether it's a source or a sink. The change in that storage is a lot less in terms of magnitude than in terms of benefit than the pool itself. It's not changing very much, in other words. A lot of the changes that you do see are caused by things that we don't have much control over, especially we in the Forest Service don't have much control over, whether we're in a drought or whether we have a lot of rain, whether it's a big fire year. The forest age structure, obviously, it's a lot like timber in that young trees grow faster, they put on carbon more quickly. There's not a lot you can do to change the forest age structure of your forest, at least not right away. So a lot of the flux that you see is based on stuff that you don't really control. And lastly, you might have a source. You might be emitting more carbon than you're taking in, but there might be a really good reason for that. I mean, that might just be a short-term process. Perhaps you are doing a lot of thinning that makes your forest more fireproof and that guarantees more stable storage of carbon in the long run. So this is sort of equivalent, going back to the bank account, this is sort of equivalent to you're making, you are maybe emitting some carbon in the short term for the purpose of maintaining carbon storage in the longer term. So, and this is probably maybe I've already said it, but this is the first time I'm going to say that all of the carbon results in these reports have to be viewed in that way. You know what's happening in your forest, and it is you who are qualified to interpret the story in each of these reports. The reports are nationally standardized, and the people who created them, myself included, are not really qualified to dig down into the dynamics of every particular forest. The planner, however, is that person. So what I'm trying to do with this video is to give you, the planner, the insight into what these results tell you, and to tell the story of your forest in terms of carbon. And I think that in your assessment, and the other assessments related to plan revision, it's the same story. Maybe you're thinning to prevent fire, or maybe you're doing a lot more harvesting to support local needs. Whatever your story is, what we're hoping is that these carbon reports will help you tell that story. Okay, so I mentioned that the planning rule, the 2012 planning rule, is really a big backdrop for these reports that we've put out. So I'm going to talk a little bit about what it does say, and then a little bit about what it does not say. So the planning rule defines carbon storage as a regulating service. It is a service, an ecosystem service, preserving water values or habitat or timber. It is one of many ecosystem services. And it requires the responsible official to identify and evaluate information on climate change and other stressors, along with, and here's the important part, a baseline assessment of carbon stocks. So what are these assessments for? To understand how the plan area plays a role in sequestering and storing carbon, how disturbances and management influences stocks, and has in the past and may in the future. And also where carbon is stored both within your forest and across the national forest system, and how that storage is changing and might be influenced by management and probably disturbances in the future. So here is a may. You may consider whether existing conditions indicate a source or a sink, and you may assess, what the future trends in sequestering, storing carbon under plan guidance. So here's probably even more, what it doesn't say is maybe even more important. There's no requirement to manage for carbon, to develop plan components to address carbon storage specifically. You don't have to manage for carbon. It's one of many ecosystem services, and you might, give it more or less weight depending on your local circumstances. The planning rule doesn't specify the scale of assessment. So instead of project scale, what we have focused on is the planning unit, the National Forest scale. And we'll see in the next video that one of the main reasons for that is a lot of the monitoring data that we've got to work with really supports inference at the National Forest scale, but not necessarily at the project scale. It's also much more efficient to think about planning at the unit scale and not the project scale. And there's also no prescription for exactly how to develop the assessment. So I'm going to say this for a second time, that the reports contain a menu that a local manager can pull from to tell the story of the forest in terms of carbon. So under the best available science mandate, you're welcome to use any information that you might have. Perhaps you have much more locally tuned, maybe you've invested in collecting great soil data. Well, in that case, you should probably use the soil data instead of your own soil data, instead of the soil data that we've implemented in these reports. But so you're not under any obligation to use anything The idea behind these reports is that it's a nationally consistent baseline, and if you don't have specifically collected local data, that it is something that will help you to respond to the requirements of the planning rule. So in summary, the assessment is mandatory, but there's flexibility in how it's collected. Since carbon is one of many ecosystem services, the assessments must be guided by local planners who have the big picture, and can place that one ecosystem service into context with all of the others. The two reports provide broad, as I said, a broad standardized analysis, but it's just a menu. It's not, you don't have to clip out everything and plop it into your assessment. I said before that it's the unit level interests that guide the reports, and in this video and in the next, we're going to clarify how to use the information in the reports to address specific needs. So the rest of this video is geared towards giving you an idea of how to apply the mandate for using the best available science, how to think about the field of carbon monitoring, and how to assure yourself that you are picking out from this report or from other sources the best available science. So, as we look at the field of carbon monitoring or carbon science, it really splits into sort of two camps. Some research is basically monitoring. So you're trying, the purpose is to describe carbon processes over a specific space and time. The other is more fundamental research, where you're looking for a rule of thumb. You're looking to understand the processes, but not necessarily linked to a specific place and time. And in fact, if you try to publish something in the literature that's geared towards understanding fundamental ecological processes, you'll have a hard time if it is only for a particular place and time. So there are really two very different purposes for these two types of carbon cycle assessment. And for our purposes, for the National Forest System, we're really focusing on the first, because we care very specifically about what's happening on the national forests. We're not as interested in, other generic landscapes. We really care about the lands that we manage and that we're responsible for reporting. I want to point out that uncertainty assessment is important for both types. It's just that uncertainty assessment for monitoring, for the type of carbon cycle science we're looking at here, it's really geared towards a local level and making inferences for your particular ownership, rather than making inferences about general systems. So as we look at monitoring systems, we realize that the most defensible assessments, the most defensible monitoring, is based upon comprehensive local real observations. And that's probably intuitive, but I'm going to say it anyway. So we want data that are not only from the area being monitored, but are collected in a way that's representative. Like the forest inventory and analysis sampling grid is designed to be representative. It's a simple random sample. And what that gives us is a straightforward uncertainty assessment. We also want data that goes back in time and is likely to be collected into the future, so that we can assess trends in a straightforward way. And lastly, we want data that are collected and quality controlled consistently across the country, so that what we say in one part can be compared to the dynamics of the forest in a different part. So as we look at the tools that are available, and in the big scheme of things, the way that I like to look at it, they're differentiated along these two axes. Analysis complexity. Some are designed just to describe what's out there, and that is a simpler task than predicting what's going to happen or what could happen. And the other axis is, in terms of differentiating the tools that people might use, is some tools are based on fairly complex models. And some tools are based on these comprehensive observations from the field or at least locally driven observations. So, as we look at putting different tools into this space, most ecosystem process models, these are the models that are used to understand generally how ecosystems work, and that apply very broadly and not necessarily to a particular place. They are, they're complex models. They are less based upon local data than something like FIA, which is measured locally at a fairly high density the same way across the whole country. But the advantage on the y-axis here, in the terms of the complexity of what an ecosystem process model can do, it's much more complex. It can predict what might happen under future climate scenarios or future atmospheric scenarios or different disturbance scenarios. And really what FIA can do is tell you what's there. So, what we see usually is a trade-off between the complexity of the tool and what it can give you and the amount of data that is used to create that answer. And it sort of makes sense because for something that's just describing what's out there, the data need is really just to look at what's out there. If you want to try to describe what might happen in the future, there's really no empirical data to cover all of the potential scenarios of what might happen in the future. So it's a little bit less empirically based. So these are the 4 tools that are presented in these 2 reports. And you're going to hear a lot more about these, the specifics of these tools in the next video, in the second video. But right now I just want to explain sort of why they are where they are in terms of the x-axis, in terms of how empirically grounded each of them is. So FIA CCT, that's basically inventory-based analysis of how much carbon is out there. That's really driven by FIA's design-based sample of field data. It's pretty straightforward, very comprehensive observations across the whole country. The product carbon analysis based on cut-sold reports, which, there's not too much modeling involved there. There is a little bit of modeling that happened with life cycle analysis, the amount of time that particular products remain in use before they go to the dump or the landfill, and then how long the carbon in those places resides until it's released into the atmosphere. But for the most part, it's a very empirically based process. So, and then we get to FORCAMP, the Forest Carbon Management Framework, and I'm going to repeat, I'm going to reintroduce you to all of these tools in the second video, but, it is a little bit less based on FIA. It is explicitly constrained by FIA, and it uses really good local change maps that come from satellites and also from NFS activities records. But it's a little bit less grounded in FIA. There's a little bit more modeling, and so that results in it being to the left on the x-axis, but also it allows us to go up in terms of the complexity of the results that we get out of it. And lastly, InTech, that is a tool that allows us to ask pretty complex questions. What happens, what's the role of changing atmosphere? What's the role of changing climate compared to the role of different disturbances, for instance, in a national forest? So much more complex questions it answers, and it is a little bit less based on empirical data. There's a lot more modeling that happens. So, but the difference between InTech and some of the other process models that are available, or all of the process models that are available in the literature, is that we were able to calibrate it very systematically with FIA data, and also to use these same change maps to really drive this analysis. So there are important ways that InTech can be calibrated to real data. So that's why that was chosen. And in general, these 4 tools were chosen to be as far to the right on this graph as they possibly could be to answer the questions that we need them for. So in talking about the best available science, our main mission was to be to the right of this, to really base our assessments on comprehensive observations, because that's really what is most defensible in court and just in general. Okay, so when you compare the outputs of these different tools, you can, for instance, you can use InTech to do what FIA and CCT does, to estimate how much carbon is out there. That is just one of the outputs. However, you would not use InTech for that purpose because CCT is available, and that's the farthest to the right on this graph. It's the most based on real data. So in areas of overlap of the tools, your thought process should always be to use the one that's farthest to the right. FIA over 4CAMP and 4CAMP over InTech. The reason we have InTech is that it just answers questions that these other tools do not. So there's an order of precedence in terms of the tools that you will find in these reports, and we're going to talk about, in the next video, we're going to talk about what to pull from these reports to address different questions. But in this video, I'm really trying to establish that these tools have been chosen to provide the best available science, and by that we mean the most grounded in real measurements, answers that we can to the relevant questions that you might ask in terms of carbon. Okay, so to summarize, more complex questions, related especially to hypothetical future scenarios require tools that are more model-driven. But in general, the best available science that means for each carbon-oriented question to use the most empirically data-driven tool that you can. So if there are any questions, my contact information is there, and I would love to talk to you. So the next video we'll be talking much more directly about each of these tools, giving you information about what they're based upon and what they're for. Thanks.